what do you know?
Hey, I like
Craig's talking. I'm going to pour it into the top. I want to show you before I do that, though, how simple it is to open just so it's easier for me to pour. And I'm going to put that material in. So I'm still pouring, about 2/3 of the way there. Just by taking it. There we go. You can see the funnel is empty.
So this machine has the ability to rotate, so you can now see in there.
So I'm just going to wipe that material away from the threads. Then once again, 2 fingers. That's all it takes to reseal this vessel. I'm going to go ahead and just dust off the top. That just keeps all the grit and hemp out of there. Now I'm going to push this unit in. I want to mention to you, gentlemen, it does not have to be engaged. It's okay to have it out. But we have a couple of methods of running I want to explain to you. I can run extractor 1. I can run extractor 2. I can run 1 into 2. Both of these are bottom flow extractors, which these continuously alternate so the machine never shuts down. You just keep putting more material in and you run continuously. You can run for days if you want to, however you want. In just about 10 minutes, we're just going to run extractor 1. So now let's see what happens. Very logical control panel. You're seeing the 2 extractors. You're seeing the 3 fractionators. You're seeing the CO2 storage vessel. We call that an accumulator. And you're seeing some of the valves that are lighted red for closed, green for open. And so you're seeing the system here. In this lower corner, you're seeing what are the recipe set points as it's labeled there, where you can see a summary of the details. So I'm going to come up here and actually touch on recipe set points. This is the detailed page. You can dial in temperatures, pressures, flow rates, the addition of a co-solvent. You can change the configuration of the vessels just with the touch of a button. So as an example, if I wanted these 2 vessels to alternate, I just come in and touch continuous. It's now configured for it. That's all I had to do. I just want to run extractor 1, so I've touched that. If you look at the picture has changed where the valves on extractor 2 are all red, meaning it's offline. So you get both a textual and a graphical representation. We're going to run this hemp. It's an industrial hemp. We're going to run it at 3,950 PSI. This particular hemp responds well to that. We're going to run that at about 55 degrees C in the extraction chamber. And then we step down through our fractionation vessels to about 3,500, 2,800, and then finally 700 PSI as we come into the final separator 3. I am flying kind of quick just to keep it short for you gentlemen. All of the temperatures are controllable. You can drive up or down because the system has full integral heating and cooling. So if you want to operate at a low temperature, you can do it. You want to operate at a different pressure, you can do it. And we will actually change the pressure during the run just to show you how easy that is. So I'm going to go back to the main process page. But first I want to point out there's some other tabs. They give you a lot of great information, but you don't have to have them if you don't want them. That's the key. There's an alarm panel that lets you know if something has alarmed. We've been playing with this machine and just verifying everything's good. So we have some non-critical alarms that are here, and I should be able to acknowledge those and clear quite a few out, which I've just done. Trends, things like time zones and printer configurations and co-solvent parameters. Co-solvent, just to hit that again for a moment, is the ability to put something else in the system besides just CO2. So maybe you're going to extract the product and you want to run some other solvent, let's say ethanol. It's already pre-built in. You merely have to go to an enable disable setting here to turn it on. And on the recipe page, I should have pointed out, you tell it how much in a percentage of your CO2 flow are you wanting to put in of co-solvent. That's it. That's simple. You want 2%, you put in 2%. You want more, you put in more. That's all it takes. So that's simple to run an advanced extraction process. We have that turned off today. We're not going to be running any solvents. It doesn't matter. I have a set of high cannabinoid for 300. It goes quite quickly. You might be able to hear the pump turn on in a moment. I'll note when it does. Now we're at 400. It's circulating the CO2. So this is a closed loop process. The CO2 is reused continually, but every time it circulates, it's purified, it's filtered, all the water is removed, the terpenes are removed, so it's purified every time it goes in a circuit. And that's a very important advantage to a KiiNjA Kinetic unit. So now we're at 640 pumps running. It's very quiet. I don't know if you can hear it or not, pumps running in the background. And this being a bit, so we're going to take a look and let's see if something's coming out already. I mean, that's like a kid at Christmas. We're pushing it.
So we're able to drain on the fly, actually while the vessels are pressurized.
Yellow whipped cream he was talking about.
Yellow whipped cream.
Yellow whipped cream.
And that's what you want. Obviously, it's yellow because there's no chlorophyll in it. That were a dark green, which is what happens with a lot of alcohol processes.
Right.
You'll get a lot of the chlorophyll. But this is free of chlorophyll. We're running the pressures right now, so we're pulling chlorophyll out in fractionator number 2 material. Don't forget, this has been totally gasified. That's a piece I don't think people understand. The purity of CO2 is that the hemp had the cannabinoid extracted by turning it into a gaseous state, moving it through the fractionation chambers, and then recondensing it out in the last stage into what you're seeing here. So that's why it's pure and clean. Because you've gone through,
That's correct.
been going for 12 minutes now. I mean, this thing's going to be full here in a minute, and we still have more material to extract from it.
Right.
So one of them is what extraction ratio you would like to run. Let me explain that briefly. So you have a solvent like CO2 or ethanol or butane, whatever someone's running, and then you have your product to be extracted through biomass. How much solvent do you want washing past the biomass? And that's a very good question to ask. We have recommendations, but you may have your own preferences. For my opinion as a chemical engineer, the best extraction, so a blend of the quickest time, but the highest recovery, right? I want my cake and I want to eat it too,
Right.
30 to 1. The reason you see this is an excellent example of the solvent ratio. The mobility of the cannabinoids and terpenes in the hemp plant are different. And that's why you're seeing the brown material now. They're really not doing the right thing. So I'm going to slip this back in so we can keep draining.